Alright, so in this problem, I have 2 to the power of 18 minus 1. So, to solve this problem for my solution, I'm going to first start by rewriting my problem. So I have 2 to the power of 18 minus 1. And let's first ignore the minus 1 here and just focus on this 2 to the power of 18. So 2 to the power of 18, this is the same thing as 2 to the power of 9 times 2. So I just wrote 18 as 9 times 2. And now an important property of exponents is that if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So in this case, I have 2 to the power of 9 times 2, and I can rewrite that as 2 to the power of 9 to the power of 2. So, going back to my original problem with the minus 1, I get 2 to the power of 9 to the power of 2 minus 1. And now 1 is the same thing as 1 squared. So I'm going to rewrite 1 as 1 squared. So I get 2 to the power of 9 to the power of 2 minus 1 squared. And the reason I did that was because now I can use this property. A squared minus b squared is equal to a plus b times a minus b. So I have 2 to the power of 9 squared minus 1 squared. So a is 2 to the power of 9 and b is 1. So now I get 2 to the power of 9 plus 1 times 2 to the power of 9 minus 1. Now what is 2 to the power of 9? Well, 2 to the power of 9 is equal to 2 to the power of 3 times 3. And remember, if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So this is the same thing as 2 to the power of 3 to the power of 3. Well, what is 2 to the power of 3? 8, right? Meaning this is equal to 8 to the power of 3, which is equal to 8 times 8 times 8, which is equal to 512. So 2 to the power of 9 is 512. So now I get 512 plus 1 times 512 minus 1. So 512 plus 1 is equal to 513. And 512 minus 1 is equal to 511. So I get 513 times 511. And now there is a simpler way. Instead of multiplying these two using the normal method, like this, there is a faster and more efficient way to do that. And how are we going to do that? Well, I'm going to rewrite 513 as 500 plus 13, and 511 as 500 plus 11. So this way, I can distribute the 500. So I get 500 times 500, which is 500 squared, plus 500 times 11, plus, now I can distribute the 13, times 500, plus 13 times 11. Now, it's much easier to solve this. 500 squared is 250,000. And 500 times 11 is 5,500. 13 times 500 is 6,500. And finally, 13 times 11 is 143. So now I'm going to add all these up. 5,500 plus 6,500 is 12,000. 250,000 plus 12,000 is 262,000. And 262,000 plus 143 is equal to 262,143. So my final answer is 262,143. Alright, so in this video, I'm going to solve the equation x to the power of x to the power of 4 is equal to 64. So the variable I want to find the value to in this equation is x. And for my solution, I'm going to first start by taking the power of 4 on both sides. So I get x to the power of x to the power of 4 to the power of 4 is equal to 64 to the power of 4. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. However, m and n are interchangeable, meaning this can also be written as a to the power of n to the times m. Now, if a to the power of m times n is equal to a to the power of m to the power of n, then a to the power of n times m, this should be equal to a to the power of n to the power of m. So x to the power of x to the power of 4 to the power of 4. In this, I can think of x to the power of 4 as m and 4 as n. So this turns into x to the power of 4 to the power of x to the power of 4 is equal to 64 to the power of 4. Now 64 to the power of 4 I can rewrite as 8 squared to the power of 4, which turns into 8 to the power of 8. Now, if I have something in the form a to the power of a is equal to b to the power of b, this means that a equals b. So in this case, x to the power of 4 is equal to 8. And to solve for x, I'm going to take the fourth root on both sides. So I get x is equal to positive or negative fourth root of 8.